Alright, in this video we're going to talk about atomic structure. So what are the subatomic particles that make up an atom? We're going to talk about isotopes and ions, and how do we represent different isotopes and ions correctly with atomic symbols. So we know that atoms are made up of three subatomic particles. We have protons. They have a positive charge, and they're located in the center of the atom. The center of the atom is very dense. It's called the nucleus. The second subatomic particle is the neutrons. They're neutral. They don't have a charge. They, with the protons, are located in the nucleus at the center of the atom, and they're roughly the same size. I should be more specific. They're roughly the same mass as a proton. And then electrons, they exist in what we sometimes call the electron cloud outside of the nucleus, right? So they're still in the atom, right? The electron cloud is part of the atom, but the electrons are not in the central nucleus. Now, electrons are negatively charged, and they're much smaller than protons and neutrons. They're about 1/2000th the mass of protons and neutrons, which are about the same mass. And I should note, just so we can make it visible, the nucleus has been blown up in this picture. If this was the actual size of the electron cloud, the nucleus would be so small that we wouldn't even be able to see it. So when we think of the nuclear model of the atom, to kind of give you an idea of how small the nucleus is the tiny, extremely dense center of the atom. And it's positively charged because it contains all of the protons and the neutrons, which don't affect the charge. And the nucleus, while essentially having the entire mass of the atom, because the electrons are almost negligible compared to the mass of the protons and neutrons, it contains almost all the mass, but it takes up only about 1/10 trillionth of the volume of the atom. And so, to give you an idea of how small the nucleus is compared to the size of the atom, which is mostly made up by the electron cloud, where the electrons are sort of whizzing around out here, if I was to take an atom and blow it up so that the nucleus was the size of one of these blueberries, the electron cloud would be the size of a football stadium. Right, so almost all of the mass is in this incredibly dense positive nucleus at the center of the atom, and then the vast majority of the volume of the atom is taken up by the electron cloud, where the electrons are flying around surrounding the nucleus. You do not have to have these masses memorized, but I just wanted to give you an idea of what types of masses we're talking about when we're talking about these subatomic particles. Right, compared to electrons, which have a mass of 10 to the minus 31 kilograms, the protons and neutrons are much larger. They're about 2,000 times bigger, but still 10 to the minus 27 kilograms. That's almost unfathomably tiny. Now, using kilograms to talk about protons and neutrons and electrons isn't especially convenient. So when we're talking about the sizes of these things, one unit that we often use, it's a mass unit. It's called an atomic mass unit. In atomic mass units, protons and neutrons have a mass of about 1. And then you can see, of course, electrons are still considerably smaller than either the protons or the neutrons. I mentioned this briefly in the video on atomic theory, but now we're going to address it more formally. What makes an element the type of element it is the number of protons. So the number of protons defines an element. And the number that we use to express the number of protons is called the atomic number. And very often in periodic tables, you'll see the periodic table written above the atomic symbol. And so the atomic symbol for aluminum is 13. That tells me that aluminum has 13 protons. And then in the periodic table, we arrange the elements in order of increasing atomic number, or increasing number of protons. So very important, I'm going to say it again. The number of protons defines an element. All aluminums have 13 protons, and anything that has 13 protons is by definition aluminum. When we're talking about the makeup of an atom, another important number is what's called the mass number. And the mass number is the total number of protons plus the neutrons in the nucleus of an atom. Now, it's really important to note, and that's why I bolded it and I put it in red and I all capped it, because this is a common misconception or common mistake that students make. This is not the same thing as the atomic weight or the atomic mass or the average atomic mass Right? All of those things, the atomic weight, the atomic mass, the average atomic mass, those are all synonyms for the same thing. That is what appears on the periodic table. The mass number does not appear anywhere on the periodic table, and we'll explain why that is. But if I have a particular atom and I want to uniquely identify it, I would do that by giving the elemental symbol. So that would be like Al for aluminum or C for carbon. I would put the atomic number in the lower left-hand subscript, and then I would put the mass number in a superscript on the left-hand side. Now, it may seem a little counterintuitive. Why do we use Z for atomic number and A for mass number? And I believe that's because this nomenclature was developed in Germany. And so if we were speaking German, the Z and the A would probably make more sense, but this is what we use by convention. All right, so a big part of the reason mass numbers are important is because the number of protons can't change for a given element. Carbon has an atomic number of 6. All carbons have 6 protons. Any atom that has 6 protons is by definition a carbon atom. But the number of neutrons can change and it will still be the same element. Or another way to say that is atoms of the same element can have different numbers of neutrons. And we call these isotopes. So isotopes are atoms of the same element, but they have different numbers of neutrons. And so if we're talking about a specific isotope of an atom, the language we would use is I would call this carbon 12, where the number I'm giving you is the mass number. Or in this case, I have carbon 14, where 14 is the mass number. And if I give you this atomic symbol, where I'm giving you the mass number and the atomic number, or I give you the name, you can tell me how many protons and neutrons there are in that atom. Right? If I write it like this, I mean, you know this is the atomic number. If I just told you carbon 12, you would still know the atomic number because I'll always provide you with a periodic table, and so you can go look up, find carbon, and you'll see that it's atomic number 6. And then to get the number of neutrons, if the mass number is the sum of the protons and neutrons, right, the mass number is the sum of the protons and the neutrons, and this is a shorthand I like to use. Right, I'll use P plus for the number of protons, right? P for proton, plus because it's positive, and 0 for neutrons, N because it's a neutron, 0 because it's neutral. To get the number of neutrons, I just have to take the mass number and subtract the number of protons. So in carbon 12, it has 6 protons, and then 12 minus 6, it has 6 neutrons. Right, whereas carbon 14, still 6 protons, but now 14 minus 6, it has 8 neutrons. All right, so we've talked about isotopes. Now we want to talk about ions. So in general, atoms are neutral. And protons have a positive 1 charge, electrons have a negative 1 charge, and so in a neutral atom, it'll have the same number of protons and electrons. So in the case of carbon, it has atomic number 6, it has 6 protons, so a neutral carbon atom will have 6 electrons. Now during a chemical reaction, I can't gain or lose or change elements from one type into another, so I can't change what's going on in the nucleus in a chemical reaction. I can change the number of electrons. So atoms are free to gain and lose an electrons. And so when an atom gains an electron, it now has more negative electrons than positive protons, and so it'll pick up a negative charge. Or if it loses electrons, it will become a positive charge. In either case, when an atom gains or loses electrons and it then acquires a charge, we call that an ion. All right, and so of course, there are 2 types of ions. They can have positive or negative charges. The name that we give for positive ions is cations, and the name we give for negative ions is anions. And one way people use to remember that, right, cations have a positive charge, right, and so the T kind of looks like a plus. So that's one way to help remember the difference between cations and anions. Now, in order for a neutral atom to become an anion, in order to become negative, it must gain electrons. And in order for a neutral atom to become a cation, it must lose electrons. So it can sort of be counterintuitive, right? When you gain electrons, you actually become negative. And when you lose electrons, it becomes positive. All right, so now we want to think about how do we incorporate the charges of an ion when we write these atomic symbols. And so we do that by writing the charge as a superscript to the right of the atomic symbol. So if we do an example, we want to write the atomic symbol for a chlorine atom, or in this case an ion, that has 17 protons, 20 neutrons, and 18 electrons. And so what we would do is we'd write the atomic symbol, chlorine. The atomic number, or the number of protons, we would write on the bottom left. The mass number is the sum of protons and neutrons. So protons plus neutrons, I have 17 protons, 20 neutrons. So the mass number of this isotope of chlorine is 37. And then for the charge, the way I figure out the charges is I usually say, okay, if this atom was neutral, it would have had 17 electrons, right? Because I can't change the number of protons, or I make it not chlorine. So a neutral chlorine would have 17 protons. If I have 18 electrons, that means it's gained 1 electron. And when we gain electrons, we become negative. So it would have a -1 charge. And so we would just put a minus. We don't put a -1 by convention. If the charge is -1, we just put a minus. If the charge is +1, we just put a plus. If I had 19 electrons, and the symbol I might use for electron is E minus, E for electron, negative because it has a negative charge. A chlorine atom with 19 electrons now would have 2 more electrons and protons, so that would have a -2 charge. That particular ion of chlorine would be 2 minus. So if it's not -1, then I have to include the number to tell you what the magnitude is. All right, so one of the ways I like to ask questions about atomic structure and about atomic symbols on tests and quizzes is give you a table like this and then ask you to fill it out. And so each row in the table represents a different isotope / ion / atom. And I'll give you some of the entries in terms of the number of protons, neutrons, or electrons, and then you need to fill out everything else. And so I have 2 examples here, and let's work through these. So first, I need to know the atomic number. And that should be easy, right? The protons and the atomic number are always the same thing. The atomic number is the number of protons. So I know that the atomic number is 27. Right, the mass number is the sum of the protons and neutrons. Right, remember, I don't look on the periodic table for this at all. Right, the mass number is specific to an isotope of an atom. As we'll talk about, what's on the periodic table is the average atomic mass of all the naturally occurring isotopes. So if I want a mass number, I want a specific isotope, and the periodic table will not give that to you. What we have to do is we have to add together the protons and the neutrons. So 27 plus 33, that gives me a mass number of 60. All right, now to get the atomic symbol, we need to know what element is atomic number 27. So for that, we need the periodic table, and I'm going to look for atomic number 27. So let's do that. All right, so here's my periodic table. Element 27 is cobalt. And notice, I don't pay attention to the average atomic mass at all, right? That's not relevant to this problem because I want a specific isotope of cobalt. So to fill this out, we have cobalt. The atomic number goes down here, the mass number up here, and then to get the charge, if this had been a neutral cobalt, the protons and electrons would have been equivalent. And so for a neutral cobalt, it would have had to have 27 electrons. It doesn't. It's lost 2. It's dropped down to 25. So when we lose electrons, it becomes positive, and it's lost 2 electrons. So this is cobalt 2+. All right, if we do the next row, I don't need a periodic table for this at all, right? Because to get the mass number, I don't look at the periodic table. This is the mass number. 131. Atomic number is 53. So the protons is also 53. All right, to get the number of neutrons, the mass number is the protons plus the neutrons. So to get the neutrons, I'll do 131 minus 53, that gives me 78. So iodine 131 has 78 neutrons. And then to get the electrons, right, if this was neutral, it would have had 53 electrons, right? But it's not neutral. It has a -1 charge. It means it gained 1 electron. So a neutral iodine would have had 53 electrons. So a -1 iodine has 54 electrons.